Okay, we're going to do the next section, which is 6 point more, basically continuing on with 6.5. We're doing roots of a complex number this time. And there will be two examples. So the first example is that I want to find the sixth roots of 1. Now, in order to be able to find the roots of a complex number, the first thing we need to have is our complex number needs to be transformed to trig form. Okay, so we have 1. So as a complex number, that would be z equals 1 plus 0I. Okay. So we need to convert this to trig form. Okay. So if I have our graph, that means it is right here at 1, 0. R is going to be the square root of 1 squared plus 0 squared. That's just 1. And theta, we can see where it's located, is going to be 0. Okay. So our trig form of z of 1 plus 0I is going to translate to 1 CIS of 0. Or again, you could write it out as 1 times the cosine of 0 plus I sine of 0. Now, there is a formula for finding the roots, and it looks like this. Your roots are going to equal whatever roots you want of z is going to equal that root of r times the cosine of theta plus 2kn, excuse me, hold on here, I wrote it wrong, not 2kn, 2 pi k over n plus I sine of theta plus 2kn over n. Okay. Now n is going to be your root. K is where we get all of our different roots. So if we're looking for like the cube root of something, or that means that there were 3 things that are a number that was multiplied 3 times. Kind of the same idea here. K is going to help us find all the different roots, because it's going to allow us to count starting at 0 up by 1 until we get to n minus 1. So in the case of the sixth roots, k is going to be 0, 1, 2, 3, 4, and 5. So we're going to go from 0 to n minus 1 so that we find all 6 roots. So we are finding the 6th roots of z, and I'm actually going to erase this. I'm going to start further on the left. You don't have to erase wherever you're at. I didn't realize how far over I was. Start over here in the middle. So we're going to find the 6th roots of z, and that's going to be the 6th root of r, which is 1. Should have just put 1 there. CIS of 0 plus 2 pi k over 6. So this fraction here, the only thing that's going to change is our k value as we find it. We're just going to increase it by 1. Okay? So the sixth root of 1 is just 1. CIS of 0 plus 2 pi k over 6. So let's just start finding them all. Let's find when k equals 0. So all we're going to do is put 0 in for k. So it's 1 CIS of 0 plus 2 pi times 0 over 6, which is 1 CIS of 0, which equals just 1. Because the cosine of 0 is 1, and the sine of 0 is 0. So it's just 1 times 1. Now, find k equals 1. So it's 1 CIS 0 plus 2 pi times 1 over 6. Simplify it, and that's going to be 1 CIS of 2 pi over 6, and that's pi over 3. If I expand that out so I can simplify it, it's going to be 1 times the cosine of pi over 3, which is 1/2, plus I times the sine of pi over 3, which is root 3 over 2. Okay, so if we were to graph it, it's up here. Alright, so that's the next root when k is equal to 1. Now let's do when k equals 2. And we're just going to keep doing this all the way down until we get to 5. So 1 CIS of 0 plus 2 pi times 2 over 6 equals 1 CIS 2 pi over 3. Okay, let's simplify that. The cosine of 2 pi over 3 is negative 1/2. The sine of 2 pi over 3 is positive root 3 over 2, with the 1 on the outside. And this one will be up here in the second quadrant. Okay, let's do when k is equal to 3. K equals 3. 1 CIS 0 plus 2 pi times 3 over 6. And that's going to equal 1 CIS. 2 times 3 is 6 over 6, just makes that pi. That's going to equal 1 times the cosine of pi is negative 1 plus the sine of pi is 0. So it's just negative 1. That one would be located here. Okay, we're almost done. Let's go to 4. Same things, 1 CIS 0 plus 2 pi 4 over 6. Simplify it. It's 1 CIS. 2 times 4 is 8 over 6. It's just going to be 4 pi over 3. Cosine of 4 pi over 3 is negative 1/2 plus, or excuse me, minus. It's going to be minus. The sine of 4 pi over 3 is also negative I root 3 over 2. That one's located down here. Now to the last one. K equal 5. 1 CIS 0 plus 2 pi times 5 over 6. That's going to be 1 CIS. 10 over 6 reduces to be 5 pi over 3. And cosine is positive at 5 pi over 3, so it's 1/2. Sine is negative. Okay? Now, let's just go back up and look at something here. I'm going to highlight just my angles. So here, this was 0, 0, and I'm going to change the opaque. Hold on here. So it's not. Okay. So that was 0, 0. The next one is pi over 3, then 2 pi over 3, pi, which is 3 over 3, 4 pi over 3, 5 pi over 3. You should notice there's a pattern. There should be a pattern with how these are increasing. So it's a good way to kind of check yourself as you go. Okay, so that's the first example. Let's go on to the second one. We're going to do the same thing. Alright, so now we're going to find the 7th roots. Of z equal to -5 square root of 3 over 2 plus 5i over 2. Okay. Now if you notice here, you actually have a GCF. We have a GCF of a 5. So if I pull out that 5, that means my z is actually 5 negative root 3 over 2 plus 1/2 I. If I graph that, that's in the second quadrant. And I find the Pythagorean theorem, I do the Pythagorean theorem of the 1/2 and the root 3 over 2. I'm going to end up with 1 here. So this is on our unit circle. So what's our theta? Well, that would be 5 pi over 6. Now remember, this number out in front was also our r, so r is going to be 5. Okay. If you didn't notice that there was a GCF, you could have also just squared the first one, squared the second one, add them together, simplify, and you would have still got 5. You would have still got 5. Okay, so let's start doing our roots. So we are doing the 7th root of z, and that's going to be the 7th root. Hold on, that doesn't look, that's not right. The 7 should be right there. 7th root of 5 CIS of 5 pi over 6 plus 2 pi k all divided by 7. Now remember, this is going to be non-calculator, so we are going to have to do some arithmetic. So let's do our first one. So when k is equal to 0, it's going to be the 7th root of 5 CIS of, this time k is 0, so I'm going to actually put it in here so you can see it. And that's going to be 5 pi over 6 divided by 7, and that's going to simplify to be 7, the 7th root of 5, CIS of 5 pi over 42, because you're going to multiply that 6 and 7. Alright, now let's do k equals 1. Actually, I'm going to move that down just a little bit. And that's going to be the 7th root of 5, CIS, 5 pi over 6, plus 2 pi times 1 over 6. So 5 pi over 6 plus 2 pi, change the 2 pi to a common denominator, so it's going to be 12 over 6, becomes 17 pi over 6. Oh, and nobody caught me. I put 6 down there, and I need to put a 7 over 7. Again, I'm going to have that 6 over 7 again, so I'm going to have a denominator of 42. So my answer is going to be 7th root of 5, CIS. Again, I have 5 pi over 6 plus 12 pi over 6. That's going to be 17 pi over 6 divided by 7, so that becomes 17 pi over 42. Okay, k equals 2. Give myself a little bit of room here. Okay, I want again the 7th root of 5, CIS, 5 pi over 6, plus 2 pi times 2 divided by 7. And that's going to be 7 pi, or 7th root of 5, CIS. Okay, so 5 pi over 6 plus 2 pi times 2, so that's 4 pi. Change it to a common denominator, becomes 24 pi over 6 plus the 5 pi over 6 gives me 29 pi over 6 divided by 7, so that's 29 pi over 42. Now remember what we just talked about, that there's a pattern here? And so we can start looking at our pattern. Well, in the first case, I added 12 to my numerator to go from 5 to 17. Did I add 12 again? Yeah, I did. 17 plus 12 equals 29. So I'm adding 12 every time. Everything else about the problem is exactly the same. So with that, I could probably jump to my next number. So this is a way to save some time. If everything else matches, and it's supposed to, and you see that there's a pattern, one, there's supposed to be a pattern. So if you don't have that, you've got a mistake somewhere, go back and fix it. Find the pattern. Just add on to your value. So 29 plus 12 is 41 pi over 42. For k equals 4. And I'm going to put these all on the same side here so that they're all lined up. 7 pi over 5, add 12 again, I get 53 pi, forgot the 3, over 42. K equal 5, 7th root, sorry about that, I forgot to write the CIS on these two. Don't forget that. Sorry about that. Let me erase those and start CIS, 41 pi over 12, CIS, add 12, oh, I'm having a bad day. Okay, let's try this again, over 42, add 12 again, 41 plus 12, 53 pi, over 42, let me slow down, 7 pi over 5, CIS, add 12 again, I get 65 pi over 42. Now to our last one, is 6 equals 7 pi over 5, CIS, add 12 again, I get 77 pi over 42. Okay? Alright. And now, if just by chance, so that we're actually done with this one. We're done. What if I did one more? If I just followed our pattern? And because we were looking for the 7th root, so what if I did when k is 7? If you look at this, and I add 12 again, I get 89 pi over 42. But if I look at 89 pi over 42, 42 times 2 is 84. So that would be one revolution around our circle. If I take 84 away from 89, I get 5 pi over 42. So this is actually in the same exact position as that first one I did. The very first one all the way up here. They're the same thing. So what we have done really is just worked our way around our unit circle, or worked around our circle one revolution. And if we'd kept going, we would just end up in the same spots. Alright, so that's the examples for this section of 6.5 roots of a complex number. If you have any questions, come to class with them, please.